My wife Anne and I photograph very similar subjects. The images in this video are a mixture from us both, except for the crystals, which are all hers. As amateurs, we choose subjects that we like and photograph them in a way that suits us. I have come to the conclusion that our fascination with macro and micro photography is based on a search for detail. We enjoy producing images that illustrate insects and other invertebrates in a way that they are not normally seen. The more detail that we can capture, the more there is to interest the viewer. Apart from when we are photographing flying insects, we generally like to get most of our subject as sharp as possible. To this end, we usually select a small aperture for depth of field and a high enough shutter speed to freeze camera shake and subject movement. When possible, we like to use stacking as a method of getting extra depth of field. As we have many more photographs than I have words to describe them, I have added some narration-free images to the end of each section of this video. Dragonflies are the largest insect that we photograph. Due to their size, they do not require a high degree of magnification, but they often fly away when approached. For this reason, we like to use a 180mm rather than a 100mm macro lens, or a telephoto lens with extension tubes fitted. Although we sometimes hand hold our cameras when photographing dragonflies, we prefer to use a tripod, especially when using telephoto lenses. Dragonflies mating seems a reasonable place to begin their life cycle. The male holds onto the female at the back of her head, while the female brings the tip of her abdomen up to the base of the male's abdomen. The pairs are quite easy to spot in flight due to their fairly slow speed. They often land in a difficult position for photography, however, such as high in a tree or on a cluttered background. Some dragonflies land on an aquatic plant and lay their eggs underwater. Others fly around, dipping their abdomens in the water and depositing eggs. Another species lays eggs in moss that surrounds water. One even tried laying eggs in my sock while I was trying to photograph it. We used a small homemade aquarium to photograph dragonfly larvae. Working with clean water and some retouching made the larva show up, but makes it seem that water may not be present. I consider the emergence of an adult dragonfly from a larva to be one of the great wildlife spectacles, but perhaps I should get out more. I think the larva itself is a natural history marvel, but the emergence of an adult dragonfly takes my appreciation of this beautiful insect to a whole new level. The following dragonfly images were taken over a number of years in various locations around the West London area. Damselflies have slenderer bodies than dragonflies and usually rest with their wings held against their bodies. We have found them to be more numerous and easier to approach for photography than dragonflies. We often see damselflies crawling up plant stems and out of the water in our pond. Subsequent metamorphosis into an adult is much quicker than with dragonflies. I photographed this damselfly as it crawled up a stick and emerged as an adult. Unfortunately, a bird flew down and took the damselfly before it could fly away. We often see pairs of damselflies landing on water lily leaves and laying eggs. In this instance, the females were partly submerged before laying eggs on the plant stem. We have taken a number of approaches to insect and spider photography. Sometimes we use available light and support our cameras on a tripod or monopod. Other times, especially when photographing fast-moving subjects, we use flash. Setting up a tripod in position before an insect moves or flies away can be difficult. Adjustment of the tripod height has to take place, and it is very easy to knock the foliage on which the insect is resting and frighten it away. There is also the matter of getting the camera parallel to the subject to get as much as possible of it in focus. When using flash, it can be an advantage to have the subject on a large flower or leaf. This puts the background close to the subject and avoids the flash fall-off associated with more distant backgrounds. Every year we plant insect-attracting flowers in our garden. This means that we only have to step outside our back door to find subjects rather than travel further afield. We are also free to step around the flowers for the best photographic position in a way that would not be appreciated in other people's gardens. Flower stem length and thickness can play a major role in photography when there is any wind. Focusing can be very difficult if an insect is on a flower that is swaying about. One answer is to support individual flowers with a cane. The movement caused by wind is much less of a problem with short-stemmed flowers such as Delosperma and field bindweed. I never get tired of photographing hoverflies, even though I've been doing so since the 1960s. There is something about their elegant bodies and the way that they fly that I found attractive. I find it fascinating to watch them collect pollen from lily flowers. I usually try to photograph bees and bumblebees from the side rather than straight down onto their backs. Occasionally, however, I will take a shot head on. Poppies and Tithonia are two of our favourite insect attracting plants because they are easy to grow and their flowers provide good backgrounds. Photographing insects in flight is more challenging than photographing them while they are stationary, but can result in more interesting pictures. The reason why hoverflies are a good choice for this type of photography lies in their flight pattern. They hover. My normal method of photographing hoverflies in flight involves using flash. This enables me to set a small aperture and a high shutter speed while keeping the ISO low for a good quality image. I usually use my flash in high speed mode and set a shutter speed of 1/1600th of a second or faster. Sometimes, however, I use my flash in manual mode and set it to a small fraction of full power. This enables me to take a short burst of shots because the flash recycles more quickly in this mode. The downside is that I have to use the synchronization speed of the camera, and this can produce a secondary blurred image if the ambient light is bright. Sometimes we use telephoto lenses with extension tubes fitted to photograph dragonflies in flight. When fitted with extension tubes, our Canon 500mm f4 lens benefits from being mounted on a tripod, but our 400mm f5.6 can easily be handheld when extended in this way. The limited depth of field when photographing insects, even when a small aperture is used, led us to the use of stacked images. This technique is very effective, but can be difficult to put into practice outdoors. When taking a single shot, subject movement can be counteracted by high shutter speed. When taking a series of shots for stacking, however, the insect and camera have to remain still throughout the process. Stacking software may be able to correct some movement of the insect as a whole, but movement of individual body parts can be more difficult to deal with. In extreme cases, the insect may fly away before this series of shots is completed. Although I have tried other methods of taking insect images for stacking, the system built into our Canon R5 is the easiest to use. Basically, I set the number of images to be captured to a high number focus in front of the subject and fire the shutter to start the procedure. I keep watching as the shots are taken and the focusing steps forward. Once all of the subject has been covered, I fire the shutter again to end the procedure. Our conventional macro lenses have a maximum magnification of 1:1. When we decided to go beyond this limit, we purchased extension bellows and fitted various lenses to them. For moderate magnification, we mounted a Nikon enlarging lens in reverse via a homemade adapter. For greater magnification, we mounted either a 4x or a 10x Nikon microscope lens, again via an adapter. Our initial attempts to take images for stacking with our new extreme macro setup involved mounting the bellows on a cross slide of a small lathe and then making the focusing steps using the scale on the lathe's control knob. The tedious nature of this procedure soon convinced us to purchase a StackShot system. Once we had fitted our bellows to the StackShot rail, we only had to set the step size and mark the near and far limits of the focus we required before pushing the start button and leaving the StackShot to take the set of images. Although we started by using our extreme macro equipment in the horizontal position, we soon made a stand for upright use when photographing pond life. Anne took this set of images of aquatic life using our extreme macro setup in the vertical position. The lighting is provided from above by 2 desk lamps fitted with LED bulbs. No filtration is involved, and so the colours are natural. When using our microscope, on the other hand, the lighting is usually from below and filtration is generally used. After some time taking extreme macro shots, we began to think of getting a microscope. My knowledge of microscopy was extremely limited, however, and has only expanded enough to buy and set up our system. I would imagine that many people who use microscopes regard a camera, if fitted, as an accessory. We, on the other hand, regard our microscope as the accessory. For this reason, we made some adjustments to the Olympus BHB that we purchased second-hand. As we were satisfied with the images we were getting with the Nikon microscope lenses we used for extreme macro photography, we decided to use them on our microscope. Although our microscope already had a tube for fitting a camera, we decided to remove the whole viewing head and replace it with a couple of homemade tubes onto which we can fit our camera. This obviously gives a setup similar in some ways to our bellow setup. Our microscope has much better subject positioning and lighting control, however, and makes it easy to add filters. Working with filters and using dark field greatly reduces the light reaching the camera sensor, and so we replaced the original microscope lamp with a high-power LED. We decided that it was essential to automate the taking of images for stacking on our microscope. To this end, we use a stepper motor connected to our StackShot controller to turn the microscope fine focusing knob. We use filtration to bring colour and contrast to our microscope images. The following images are labelled according to the filters used. As the lenses are a fixed distance from the sensor on our microscope, we can only change the magnification by changing lenses. If the subject is too large for our 4x lens, we take side-by-side images and then combine them when editing. The following images were taken using either a 4x or a 10x lens. In midwinter, when there are no insects about and it is too cold for pond dipping, a good alternative may be to stay indoors and do some crystal photography using a microscope. The colours in these images are produced by using one polarising filter above the subject and another below. The crystals would be virtually colourless without the filters. The substances we use are inexpensive and easy to obtain. Sometimes we use them singly, other times we mix 2 or more together. Here is a list of some of the substances we use. We make up saturated solutions and then filter them to remove undissolved residue. It is necessary to add a few drops of wetting agent to make the solution spread evenly across a microscope slide. We use a cocktail stick with a point cut off to do the spreading. The final appearance of the crystals on a slide depends on a number of factors. The substances used obviously have a marked effect on the final result. Other contributing factors are the thickness of the applied solution and the drying time. We usually start off by placing a slide on a radiator and then remove it to a place at room temperature to finish crystallising. The look of the crystals formed is quite sensitive to small changes in substance ratios and drying conditions. This means that it is easy to get a variety of images without a great deal of effort. Sometimes we spread a continuous layer across the slide. Other times we make separate small dots of solution. We dragged out the dots with a pin to form these images. After seeing the effect of a cat hair that was accidentally introduced onto one of our crystal slides, we tried a few slides with cat hairs added on purpose. The following crystals are mixtures of various substances. I'm not sure how well water drop photography fits into the macro category, but I decided to include a few images anyway. The timing of the water drops was done electronically. Up to 3 different coloured drops were used per image. Further colours were introduced by filtering the light from the 2 flashes that provided the illumination. I also used coloured reflectors. The flashes were set to manual mode at their lowest fractional setting. I believe this gives an effective exposure duration of around 1/8000th of a second.